asked for each of the given functions to determine the domain, horizontal intercept, vertical intercept, and then sketch an accurate graph. If you look at our first function, f of x equals the square root of 4 minus x. Remember there's a 2 here. This is a square root function. Because it is an even root function, then I must have only positive numbers or 0 underneath the radical. So the domain is going to be 4 minus x greater than or equal to 0. I want whatever is under the radical to be greater than or equal to 0. To solve this inequality, I'm going to add x to both sides. That's going to give me 4 is greater than or equal to x. If I rewrite the order on this inequality, I can say that is the same thing as x is less than or equal to 4. So this is one way to write the domain for this function. If I want to find the horizontal intercept, then I want to take and set what's underneath the radical to 0, because I want to know what value of input is going to give me an output of 0. That's the location of the horizontal intercept. Because it's on the horizontal axis, the output is 0. So when I'm working with the square root, if what's under the radical is 0, the square root of 0 is still 0, so I can just focus on this part and set this part to 0. So if 4 minus x equals 0, then 4 equals x. That means my horizontal intercept is 4, 0. To find the vertical intercept, I want to evaluate the function when the input is 0. So f of 0 is the square root of 4 minus 0. That's the square root of 4. The square root of 4 is 2. So my vertical intercept is going to have input of 0, output of 2. Let's go over to our graph, go to our y equals. Let's clear out anything that is in y1 and or y2. And let's enter the function f of x equals the square root of 4 minus x into y1. I'm going to use my arrows to end the radical after the x. Let me check my window. I'm going to take and make sure that my window is -10 to 10 for both x min -10, y min, and then x max and y max of 10. And let's press graph. So this will give us a good idea, and we know what some of these ordered pairs are. So if I go ahead and draw my grid here, there's my vertical and my horizontal axis, and then I'm going to draw just the basic shape of the graph. This is f of x, and I know that this is the ordered pair 0, 2, and that this is the ordered pair 4, 0. And I should have probably drawn this a little bit farther over. See how it's kind of flatter here. So you can do that on your own paper and make it look more representative of this graph. But we've got the labeling, we know where these points are, and we have the basic shape. Let's look at function g of x and take the same approach. So g of x equals the square root, I'm going to put the 2 here, of x minus 4. Once again, for a square root function, we want what's underneath the radical to be greater than or equal to 0. If I add 4 to both sides now, that means x is greater than or equal to 4. That is my domain. To find the horizontal intercept, I take what's underneath the radical, set it to 0. I'm going to add 4 to both sides, so I have the same horizontal intercept as I did for the other function. Let's look at the vertical intercept. I'm going to evaluate g of 0, and that's going to be the square root of 0 minus 4, which is the square root of -4. That is not a real number, which means, I'm going to say implies with an arrow, there is no vertical intercept for this function. So let's go to our y equals, and let's clear out what we have, and let's enter the square root of x minus 4. And I'm going to leave my window the same. I'm going to take my right arrow and end the radical at 4, and I'm going to press graph. So I can see that I have a different kind of a shape from the first graph. Let me draw my vertical and horizontal here. It's actually going to start at the same horizontal intercept as what we had before, but then the graph is going to go off to the right. This is 4, 0, and notice that it does not cross the vertical axis.